Hi. So I think everybody is just joining in right now. We have about one more minute or so until we get started. But thank you guys for joining us today.
Hi, everybody.
Hey, everyone.
We'll do introductions in just a second. We're just getting everybody logging in. Okay. Well, it's 10 o'clock, so I don't want to keep everybody waiting too long. Good morning as well. Just to introduce myself, Kelly Cabal. I am with Contech. I'm based here in the States and doing business development, although my background is mostly on CPT as well as site investigation. And we have Jeff Schaefers is sort of helping me out here with answering a little bit of questions. Jeff, did you want to introduce yourself real quick?
Hi, everybody. My name is Jeff Schaefers. Yeah, here to help with some Q&A in the background here while Mike's presenting. And I look after business development in Canada.
Perfect. And we are joined today with our speaker, Mike Parkinson. So he's based up in the Vancouver area and has been with Contech for about 20 years. Has done everything from operating to CPT, operating drill rigs and managing projects as well. So for our 101 series, today we're going to cover sonic drilling and hopefully everything you ever wanted to know about sonic drilling. So Mike, I will turn this over to you. I think we will start with a poll question really quickly, just to kind of see a little bit of what industry most people are coming from. I guess it only lets you choose one, so maybe predominant industry here. And I know we still have some people joining, so we'll just give you guys another 10 seconds on this. It looks like a little over 50% in civil and infrastructure, and maybe about 36% in mining, 7% in environmental, and we have a little bit of energy. And oh, there's a couple students. We're at 1% right there. Maybe they're joining in. So we'll let the last few people answer. It's probably a window that would have popped up for you guys. And I guess maybe while this is up, we'll go over a few sort of operational things. There is a chat feature, but we'd prefer for you to type in any questions you have in the Q&A portion of Zoom. And then we can help potentially answer some of those as we're going. And I think you can actually upvote questions. So if you see a question there that's the same as yours, you can sort of vote for that one, and we can have Mike answer those at the end for everybody. And so, yeah, the Q&A is the best way to do that. The webinar will be recorded, and within a day, we are going to send out the video recording in an email to you guys. So everybody attending today will get the PDH certificate. That might take a couple days. It just has to be done slightly different, but at least within a day, you'll get access to the recording, as well as everybody who signed up but wasn't able to participate. If they ask about it, it will also have the link to the recording, and you can share that with your colleagues as well. Okay, so let me end this poll. I'll just quickly share the results so you guys can see the split there. So thank you, everybody, for joining in. Okay, Mike?
Yeah, awesome. Thank you, Kelly. Thanks, everyone, for joining. Just get this started here. Okay, so welcome to Sonic 101, an introduction to sonic drilling. We'll talk a little bit about how sonic works, the advantages and limitations, common misconceptions, and then we'll talk more about capability and geotechnical and environmental applications. Starting a little bit with our own history, Conetech was founded back in 1985, and the first CPT we ever pushed was actually deployed from a mud bay drilling rig here in Western Canada. Mud bay drilling has been providing drilling services since 1972, so for over 50 years. And we added sonic drilling services back in 2002, so over 20 years ago. We did that in collaboration with ProSonic, and ProSonic was later acquired by Boart Longyear. So Conetech acquired mud bay drilling back in 2015, and that was really just formalizing our kind of 30-year relationship at that point in time. Since then, we've continued to develop drilling services throughout the Conetech offices and around the world, and we've been leveraging the experience and knowledge brought by mud bay's 50 years of experience. And then more recently, we added the geotech group of companies to the Conetech group at the beginning of this year, actually. And that brought even more experience and knowledge to the combined group. So the Conetech group of companies, I talked about Conetech and Mud Bay already. There's also Mikisew Conetech, which is in Northern Alberta, and it's a partnership with the Mikisew group. They service the Alberta oil sands. And then, like I mentioned, the geotech group joined at the beginning of this year. They are geotech drilling, all service drilling, and geotech ecutech in Northern Canada. We got another poll here as well. This one's just, what's your experience with Sonic? And I think Kelly will put that up.
Yes. Let me get rid of this one.
We'll just give that a second. Maybe while that's happening, I'll start with some Sonic basics here. So the basics of how sonic drilling works is that it uses high frequency vibrations to advance the drill string and the bit. The vibrations are produced by two counter-rotating weights in the head, or eccentric weights, which is essentially the oscillator. These weights are timed to each other, so the lateral forces are equal and opposite, and they cancel each other out, and the vertical forces are equal and in the same direction. So it only transmits forces vertically down the drill string. Typical frequencies are in the range from 50 to 150 hertz. I would actually say that 150 hertz is more typical than anything. So at 150 hertz, these oscillators are spinning at 9,000 RPM. The oscillators are isolated from the rest of the drill rig with like an air spring or rubber dampers or something of the like. And then the drill string is advanced using both vibration and rotation, sometimes without rotation though. The sonic vibration on the drill string fluidizes the surrounding soil, which greatly reduces skin friction on the drill string, the core barrel, and the casing, and then it easily displaces the soil around the bit. There's carbide buttons on the bits and shoes that can pulverize rock or consolidated formations so that you can achieve this displacement with the core barrel or casing. So the traditional sonic coring in North America would be 4x6 coring, or that's what we call it. That's a 4-inch core with a 6-inch casing. And that's what I'll refer to as traditional sonic coring from now on. So the first step is that the barrel is advanced into the formation using both rotation and vibration. You're not using any fluids or water at this time. Once you've advanced the barrel, you can stop and disconnect from that. And the core or the sample is inside the barrel at this time. The next step would be to connect to your casing or your override casing, and you'll actually override that casing over top of the core barrel, which is already in the formation, again, using vibration and rotation. And at this time, you'd use some water or flushing media to keep the annulus clear between the casing and the core, or casing and the core barrel, but the core itself is protected inside the core barrel. and not subjected to whatever flushing media you're using. Once you've met the same depth as the core barrel with the casing, then you'll disconnect from the casing, reconnect to the core barrel, and pull the core to surface and extrude it. We have a nice animation here that'll run. So this animation depicts one of our compact sonic drills, so smaller, shorter stroke drill rig, but still 150 hertz and 50K. The yellow door there is the rotation guard, and then that's the casing presenter or rod presenter. Usually have casing racks and rod racks on site and some kind of support equipment like a skid steer or small loader. So then this is the core barrel being advanced into the formation, again, rotating and vibrating. You can see the core goes inside the barrel. And then the casing's overridden over top of that. And the barrel's attracted back to surface and the sample extruded. Right. Did we get the results of that poll, Kelly? People's experience with Sonic?
Yep, I did. I posted it for a little bit. Let's see if I can share results. Yeah, so the experience is about 50-50 as to completely new to Sonic or a little experience. There's just a few frequent specialists on here.
Great. Okay. Great to know. Thank you. Okay, so that was kind of what we call traditional sonic coring, or what's traditional in North America, and that's that 4x6. There's of course other methods and uses for sonic drilling, as well as adaptations to the traditional methods. The main one being that there's various flushing medias. So water, I would say, is the standard, but you can use air and mud and polymers. There's options for dry drilling, which I'll try to explain a little bit later. You can drill open hole in formations that accept it. There are wireline options available. You can washbore casing alone. And then there's a ton of different bits that you can use to help kind of maximize sample recovery or just increase production rates. And then there's various sonic samplers. One that we're pretty familiar with is an Aqualock sampler from Igelcamp. It doesn't actually require any casing, and it's very, very good at collecting sample in very soft soils. And there's just a lot of other options as well beyond the traditional sonic coring anyways. I did want to present some photos of sonic core in case you guys haven't seen it or you're not familiar with it. This is a beautiful sonic sample of well-graded sand with some small gravel in it. This is kind of cobbles with some fines and clay. And what's interesting, these are larger diameter, I think 8-inch core. So you actually get entire cobbles in there, so you can find out what size the cobbles are. This is more cobbles. It's probably 4-inch minus, and it's quite angular. Again, large diameter and collected full cores with it. These are, I would say, gravels and clay. And then another really good shot of a very mixed formation with some consolidated materials, some gravels and cobbles and fine grained material, all with excellent recovery. Permafrost. So sonic coring is actually very good for permafrost. You can drill without water, or you can drill with brined and chilled water and collect good quality permafrost cores. There's more permafrost. And then we're getting into probably soft rock here, and then hard rock or harder rock. That's probably granite in Western Canada. And then this is actually a really interesting example. This was a mini sonic rig installing some wells. They encountered a granite boulder pretty close to surface, actually. Managed to drill through it and install the well. And when they were pulling the casing back out, the boulder actually got caught on the casing shoe and came out of the hole. So you can actually see the well installed in that hole below there. And then it gave us the opportunity to take this very cool picture of the granite boulder with the casing shoe, the core barrel bit, and the core that they took out of that granite boulder. This is just showing that we can and have drilled through steel. Those are chunks of railroad, I think mostly for demonstration purposes. And then that's an 8-inch diameter core of a steel reinforced concrete, which is, again, no problem to drill with sonic. So speaking to the advantages of sonic drilling, the typical claims, especially that you'll hear from manufacturers in particular, is that it's three to 5 times faster than conventional methods. It produces up to 80% less waste than conventional methods. It's straight and accurate, often with less than 1% deviation. You can collect high quality core in all unconsolidated formations. It produces a fully cased hole. And the big thing is that it gives you this versatility and confidence in your site investigations, because you know that you can drill through any formation and collect samples. So in my opinion, there's the 2 real primary advantages, and that is that kind of quality, versatility, and confidence. So you know that you can drill, sample, case, and collect core in all these formations. So flowing sands, gravels, conglomerate, till, and so on. If it's a difficult site or difficult conditions and you need sample for sure, then sonic drilling is going to be able to provide top quality core samples in nearly any formation, and also to significant depths. You should consider that if you don't need sample, there may be a more efficient way to do it. Or if it isn't difficult or an unknown formation, then there may be more cost-effective ways to do it as well. But if you know it's difficult, or you don't know what it will be, and you need good sample, or you need sample from deep depths, or you really need a cased hole, then that's a major advantage of sonic drilling. The other huge advantage, in my opinion anyways, is this ability to handle, advance, and use casing to extreme depths. So it's easy to advance casing. It's easy to adjust your casing. You have this ability to clear and flush your casing at any time, and adding the vibration to that makes it a lot easier to work with. The ability to override and telescope your casing as required. So if you needed to telescope a hole, you don't need to start with a large diameter. You can drill until things get too difficult, and then you can override one size larger to free everything up, and then continue on extending your borehole. They have common casing sizes from 4-inch all the way up to 12-inch. And it just produces this clear, fully cased hole for very high quality installations. And having the vibration option nearly eliminates any concerns about bridging, slough, or sand locking. These are some good diagrams from, actually, I think back in our ProSonic days, again, talking about the casing methods with sonic. So it's very, very good for well installations and provides high quality well installations. So you're drilling and sampling, collecting a continuous core. You can see what the formation is that you're in, and you're advancing casing the entire way. You're only using clean water, so there's no muds or polymers or anything like that in contact with the borehole. And you have this really good contact between the casing and the borehole wall. Then you can install your monitoring wells or other types of wells inside of there. And as you pull back the casing, you end up with very good contact between the between the filter sand and the borehole wall, as well as your seal and your grout in the borehole wall. in these diagrams, they compare it to auger, and you're drilling an oversized hole with an auger. The cased portion is much smaller than the hole diameter. And then as you pull the auger back, your sand and your grout is mixing with slough and cuttings as you're exposing the screen. So you just don't get the same quality of well installs. And then you also run the risk of bridging and sand locking. I talked a little bit about the multi-casing. And being able to override casing and the different diameters of casing. This is an interesting advantage, again, from back in our prosonic days, being able to use this multi-casing method to isolate contaminated zones. So if you're drilling to install monitoring wells for an environmental program and you have a contaminated zone overlaying a confining layer, you can drill traditional 4x6 sonic into the confining layer, collect samples the whole time, know what formation you're in, and then once you hit that confining layer, you can override a 7-inch casing or a larger diameter casing and set that into the confining layer, which essentially isolates your contaminated zone from the drill string, and then advance your drill string on and don't have to worry about dragging contaminants downwards. The photo on the right is just a very cool photo that we'll talk about later of all the different casing sizes telescoped on a deep hole that we completed. Another advantage is that it's very straight and accurate. It's partly because it uses vibration, like the vibration is doing the work, pulverizing the formation and displacing the formation. So you're not really pushing on the bit, which is often what causes your bit to deflect and your hole to deflect. The other thing is just because of the methodology where the casing is always chasing the core barrel and then the core barrel is always being guided by the casing. And cool picture on the right shows that's a 4-inch core barrel with a 6-inch casing, 7-inch casing shoe, and 8-inch casing shoe. So you can see how tight the annulus is between all the different sizes of tooling. So I do have a couple example projects, and I think that segues well into this one. This first one is a mining project in Canada. And what they needed to do was install instrumentation at the toe of this waste rock facility, but we couldn't access the toe of the facility for environmental reasons. It was an environmentally sensitive area, so you couldn't bring a drill rig into there. So the solution was to set up on one of the benches and drill at an angle through the waste rock, through the overburden material and into the bedrock at the toe of the dam so we could install these instrumentation. In the end, it was about 770, let me see here, it was about 700 linear feet of angle drilling on a 30-degree angle through the waste rock, and then a small amount of overburden and then rock. So we had to override casing quite a few times because that kind of pressure on the casing, especially drilling on a 30-degree angle, got pretty high anyways. So in the end, they deployed a total of 570 meters or 1,870 feet of casing installed. And they managed to slot the 4.75-inch casing into bedrock, install HQ, diamond drill the bedrock formation, and then install triple nested vibrating wire piezometers. They also logged the hole for inclination, and they found out there was less than 1 degree of measured deviation along the entire length of the borehole. Another advantage is speed. The typical claim is that it's three to 5 times faster. I'd say it depends on what you're comparing that to. It's not going to be any faster than augers if you just need grab samples to 20 feet in auger material. And it's not going to be any faster than, say, wireline coring if you're in material that you can core at depths of 500 feet or so. And that's simply because it isn't wireline. But where it is very fast compared to other drilling methods is when it's difficult conditions and you need samples and you need a cased hole. So 100-foot holes in heaving sands or coarse gravels, where sampling is required and instrumentation required at the end, it's going to be very, very fast and considerably faster than other methods. You do also need to consider what sonic rig you're using. There's different sizes. There's different rated power of the rig. There's different rated power of the heads. there's different stroke, and there's different methods for rod handling. So the photo on the right, for example, is one of our long stroke drills. That's actually me on a project in Arizona. And that rig handles 20-foot rods vertically. And I think that's about 12 rods in the rack, which is 240 feet. It only takes about 6 minutes to trip that 240 feet in on this rig. But if you're on a rig that used 5-foot tooling and you had to lay it out, you know, it might take well over half an hour to trip those rods. So that does have a very big impact on the production rates with sonic drilling, because the core barrel is tripped in and out on the rods for every single run. Uh-oh. Did I lose you guys there, Kelly, or am I still?
No, you're good. You
Okay.
switched to the presenter view for a second, but now it's back.
Okay.
Yeah.
Cool. Good. Okay. Sorry, carrying on here. Yeah, my slides are not advancing anymore, are they? Try that. There we go. Okay, another advantage is there's up to an 80% reduction in waste. That's at least what the typical claims are. I believe that they're comparing that to hollow stem augers. It's true that there's nearly zero cuttings produced from traditional sonic coring, other than the core that's collected itself. And that core, if you were disposing of it, is usually less than a 45-gallon drum for 50 feet of drilling. Dry drilling does produce about 50% more cuttings or more cuttings in some way or form. But then another thing to consider is that there's varying amounts of wastewater being produced, depending on the formation. But there's no muds, bentonites, or polymers with traditional sonic coring that you need to dispose of. And there's many methods to control and collect that return water. Okay, so dry drilling is one of the major advantages, and I will do my best to explain it with a diagram here. So there's a couple of methods, and the method that's in the diagram here is commonly referred to as the rat hole method. So in this case, you would advance your core barrel into the formation 10 feet if you're using a 10-foot core barrel, and retract it back to surface before advancing your casing. Then you advance your casing, and the cuttings and slough that it produces falls down into the hole that you drilled where you collected the sample with the core barrel. So you only advance the casing 5 feet, and you leave the bottom 5 feet open to collect the cuttings and slough. Then you send your 10-foot core barrel back down again, and the first 0 to 5 feet is going to be the cuttings and slough that you've produced advancing your casing, and then you're going to advance 5 feet into new material and collect 5 feet of new core. Extract the core barrel again, and then you just advance the casing 5 feet again. Then you repeat this over and over again to depth. So essentially, you're using a 10-foot core barrel to collect 5-foot cores each time. This method does require the hole to stay open, or open enough for the cuttings to fall down into this hole when you advance the casing. The other option would be that you drill a 10-foot core barrel in and extract it, and then you advance your casing 10 feet, and the cuttings and slough end up inside the casing. Then you can send your core barrel back in, clean out the cuttings and slough, trip your core barrel back out, discard the cuttings and slough, trip your core barrel back in, and take your 10-foot core, and then repeat this over again. So in that method, you're collecting 10-foot cores, but you're running 2 trips for every core. In the first method, you're using 10-foot tooling to collect 5-foot cores. But the first method can be quite efficient if you have a long stroke machine that can use a 20-foot core barrel, because then you can still advance the borehole 10 feet at a time with each run. There are some considerations when you're thinking about using sonic drilling. I think water requirements are one of the big ones. Traditional sonic coring or 4x6 sonic coring uses water to cool the bit and to clear the cuttings from the annulus when you're advancing casing. There's dry drilling methods, but they do have lower production rates, and they do they do produce more cuttings. The water consumption does vary greatly by formation. So coarse materials typically take the water as you're pumping it. You don't get any return. And fine materials typically return the water back to surface. So if you're drilling through coarse or dense gravels, for example, it's slower, tough drilling, and you're just pumping water the whole time. You need a good water supply. Similarly, in stiff, fine materials, it could still be slower drilling and you're pumping water the whole time, but then all that water is returning to surface. But yeah, the water consumptions and needs can be managed to some extent. So you can go to no water requirements, but you sacrifice production rates for that. And in general, having a good continuous water supply can greatly increase your overall production rates with sonic drilling. Another thing to consider is that traditional methods does include extending casing to full depth. So cohesive or sticky formations, they can be challenging, and then deploying override casing to be able to continue advancing the hole can be time consuming. So there are options to add polymers and muds to reduce friction, but then you lose that advantage of water only or dry drilling. So it can be inefficient if casing isn't required. In the same thought, traditional sonic drilling includes collecting core samples for the continuous core for the borehole. If you don't need continuous core, then it can again be inefficient. There's options to drill without collecting core with one of those full face bits or just by advancing casing. But again, the traditional sonic drilling we're talking about includes collecting core the whole way. And if you don't need that, it can add time. There's no reliable wireline sonic options available on the market, at least in our experience, and we've tried quite a few, and we own a couple of wireline sonic options, and mostly that they just don't work in all formations, particularly sands and gravels. So the core barrel does have to be tripped in and out of the hole on the rods for every single run. So that, coupled with the need to advance casing and then override casing as you get deeper, it can result in exponential decay in production rates with depth. So you can drill and sample very deep with sonic, but because you're collecting core and advancing casing the whole time, the speed and overall production rates does decay as it gets deeper. Some of the most common misconceptions that we hear anyways is that sonic drilling is only for environmental drilling, or sonic can't be used for geotechnical testing or sampling. The samples are disturbed. Sonic is expensive. Sonic is ultra specialized. Or one that we really do hear a lot is that sonic didn't work or it doesn't work or we already tried it. So addressing some of these, the first one being that it's only used for environmental drilling. I do believe that it's widely considered as primarily for environmental drilling in North America. In fact, the ASTM for sonic drilling talks about it being a geoenvironmental drilling method, but it is used all over the world for all kinds of applications, and from environmental to geotechnical to geothermal, exploration, and more. In our own experience, we know it's very common to do geotechnical tests such as SPTs and LPTs. SPTs are also noted in the sonic drilling ASTM. We've collected thin-walled tubes, we've deployed CPT, done vein shear testing, DCPT, as well as borehole geophysics inside the steel casing. So continuing with these misconceptions, there's this misconception that you just can't be used for geotechnical work, and that's because the samples are disturbed. So to begin, disturbance and sonic disturbance in general is a big topic, and I'm not an expert by any means, but there is a couple things I'd ask you to think about or consider. It is common practice all over the world, some places more than others, and in the subregions more than others. But it is common practice to collect SPTs and LPTs and even Shelby tubes from traditionally drilled sonic boreholes. Within our group, we deploy CPT and vein shear in sonic boreholes all the time. It is a high frequency vibration, but you should also consider the fact that it's very low amplitude. So if you compare that in relationship to a downhole hammer or even a hollow stem auger being forced into the formation, you could argue that low amplitude, high frequency is going to cause less disturbance than the high amplitude, low frequency of a hammer or just the act of forcing augers into the ground. You could even consider mud rotary drilling, the fact that it's widely accepted as the best method for geotechnical testing. If they don't take the proper care with pump pressures and pump flows and bit pressures, you can so very easily disturb the soil and jet the soil and get very poor quality SPTs or Shelby tubes. So there's options to reduce disturbance in all drilling methods, including sonic drilling methods. I'd also consider what you're using the samples for. If it's just Atterberg limits or sieve analysis, or even just unified soil classification, anything you would do with an auger, I would very strongly argue that you're going to get a much better quality sample with a sonic drill that'll be less disturbed. I use the same picture of the well-graded sand core again because it's an absolutely beautiful sample, and I don't think that there's any other drilling method that can collect a sample of that quality. It would have lost some portion of that, maybe the fine materials, maybe the coarse materials. You just wouldn't get that quality. There's options to combine sonic drilling with other methods, including mud rotary, and I'll talk about that a little bit later in the presentation. And then finally, there are studies out there. We've been part of some studies and papers that were published with UBC and UC Davis addressing the effects of sonic drilling and disturbance on CPT data. I have a bit of info on that here. So this is some data we collected internally at one of our test sites. As I mentioned, UC Davis has some ongoing research on the topic. Reference to the current findings were presented in 2021 at the Canadian Geotechnical Conference in Eastern Canada, I believe. So these tests were completed by advancing traditional CPT, and that is the black trace here. The black trace, that's our traditional CPT. And then we also did a push drill push CPT with sonic. So that's where we would push the CPT to a prescribed depth, and then we would drill out, and then we'd put the CPT back in and push to a prescribed depth, drill out and repeat. And that's our red trace here. So you can see where we drilled out to 20 meters. This red trace overlies the black trace quite well, and then it starts low and increases again. And then again, we drilled out to 23 meters, starts low and increases. So yes, more data is needed. However, we see the measurements are kind of 0.2 to 0.7 meters below the sonic casing. They generally show lower values in the post-sonic soundings, so 25 to 90% smaller than the baseline measurements. So the data here does indicate some sonic-induced disturbance. It might be the result of the vibrations, or it might be a lack of confinement or heaving material or jetting, and those would have been present with other drilling methods as well. In any case, it's limited to about 60 centimeters in this example, or 24 inches. And I know in our world anyways, we've always used a rule of thumb for a disturbance zone to be about 5 times the diameter of a tool. So with a 6-inch sonic casing, 5 times the diameter is about 30 inches. So we're well within that kind of regular rule of thumb of how much disturbance there is. And I would argue that beyond that 30 centimeter disturbance zone, it's very high quality CPT data returning the same kind of tip resistance and pore pressure.
Mike, I'll just pop in here because there were a couple of questions about that disturbance. Would you say it's the same amount also for like horizontal spacing? Let's say if you wanted to put a CPT next to a previous, sonic borehole.
Yeah, we've always kind of considered it a ball that's 5 times the diameter of the tool that you're drilling with. And that would be with any drilling method, including augers.
Great.
Okay, and then, the sonic is expensive argument. True, sonic drill rigs are expensive in relationship to other rigs of their size. They're expensive to maintain. The tooling is expensive. So therefore, the operating rates can seem expensive. But I would consider, as discussed the sonic drilling is fast. So consider your cost per linear foot of your total investigation, installation, or exploration. Think about the total time on site and the external impacts that might have, permits and other contractors on site, the oversights or adjacent operating costs. Think about the waste disposal, think about the contamination, and then, of course, the intangible costs, right? What would it cost to go out and do the job twice because you couldn't get it done the first time? If you don't know the site or you're expecting challenging conditions, sending a sonic rig the first time and getting everything you need, including high quality core, can make it a lot more cost effective.
Is there a rule of thumb on like a percentage more that it tends to cost per day compared to rotary drilling or auger drilling?
Yeah, not
It
in my
really
experience.
varies.
Yeah, just because it varies by region so much. Yeah, I couldn't even give you a general ballpark rule of thumb. I will say that it is, I would fully agree that it's more expensive in a cost per day or cost per shift, but I think you can get meter rates very similar to rotary drilling, and even auger drilling. And then the Sonic didn't work or Sonic doesn't work or we already tried it argument. Um, I think it's very important to understand that Sonic is not Sonic is not Sonic. They're not all the same. Um, and it's not ultra specialized either. It's not that only a few contractors do it. The idea is probably more prevalent in some regions than others. I know it's Sonic is super common in Western Canada, but I know there's parts of the US and other parts of Canada where it's not as common, and it seems like it's this very specialized thing, but it really isn't. I think a lot of Sonic contractors actually treat it more specialized than it is, and I can say that because I am a Sonic drilling contractor. Uh, but the fact is that Sonic's been around. The Sonic that we know today has been around for decades. Like modern Sonic drills that we use today have been operating for over 30 years, and the basic rigs and principles haven't really changed. There's numerous small manufacturers building Sonic drills using common heads. There's about 10 common Sonic drill heads in North America, ranging from 25K to 50K, and then like 60 to 150 hertz. And I'll talk a bit more about what the 25K, 50K, and the hertz means. And then there's also other types of resonant heads available that would be considered Sonic as well. So there's this big range of equipment, and not all rigs are equal, right? Some of them might be small and nimble and might have limited capabilities, and others would be very large and you might not be able to use them on your site, but they might have very extensive capabilities. So it's not all the same thing. And then there's, of course, the range of experience and skill level with contractors. There can be contractors that have been doing it forever, but have only been using, mini Sonic rigs for this particular type thing. Anyways, I just urge you to not consider all Sonic rigs to be the same and all contractors to be the same. Building on that a little bit more, I wanted to talk a little bit about the details with Sonic heads in particular. So the heads are typically rated on the force produced by the oscillator. So when you hear people talk about a 50K head, they're talking about a head that produces 50,000 pounds of oscillating force. So a 50K head that works at 150 hertz or rated for 150 hertz, it only actually reaches that 50,000 pounds of oscillating force at 150 hertz, because the oscillating force is directly related to that angular velocity of the oscillator or the weights. So it's proportional to the square of the frequency actually. So 150 hertz 50K head operated at 75 hertz only produces 12,500 pounds of oscillating force. What's more important than the oscillating force, though, is resonance. And resonance occurs when the sonic head frequency matches the natural frequency of the drill string in the formation, or one of the overtones of that natural frequency. So an overtone is any whole multiple of the natural frequency. So if the natural frequency is 50 hertz, then an overtone would be 100 hertz. The next one would be 150 hertz, 200 hertz, and so on. So the energy that's transmitted through the drill string from the head and to the bit is at its absolute highest when you're in resonance. And then on top of that, the skin friction on the casing or core barrel, both the inside of the core barrel and outside of the core barrel, is the lowest when resonance is achieved. So the natural frequency, it changes depending on the conditions and the confining conditions and the length of the drill string. The confining conditions and condition side of it is ultra complex, and I'm not the person to explain it, but there's an important point about that, and that's the length of the drill string. So an idealized formula for the natural frequency of an unconstrained steel pipe, so a drill string we'll call it, would be C, which is a constant, a speed of deformation. That's about 16,500 feet per second in a steel pipe, over 2 times the length of the pipe. So if we ignore the fact that there's external conditions, the natural frequency of a 100-foot steel pipe is 82.5 hertz, which means that the first overtone is 165 hertz. So with a 150 hertz, 50K sonic head, you wouldn't reach the first overtone. So to work in resonance, you'd be working with 82.5 hertz, which is only just over 15,000 pounds of oscillating force, not the 50,000 pounds that you could get out of the head. A 50-foot steel pipe would actually be 165 hertz, and a 400-foot steel pipe would be 20 hertz, and then overtones at 40, 60, 80, and so on. So of course, this isn't the case in practice. The natural frequencies are typically a lot lower than that, based on the external forces as well. But the idea here is that the longer the drill string, the more overtones you have to work within, and the more resolution you get to get the most out of your sonic heads. So in practice, though, drillers are constantly adjusting feed pressures, rotation, and oscillator frequency, as well as even pump pressures, trying to achieve resonance. And currently, it's all done by sound and feel and experience, really. So there are some groups out there trying to assist with this by instrumenting the sonic heads and then using models to predict the resonance frequencies. And then they give the driller a gauge, actually, to help target and achieve the resonance. One of them is SciEx, and I think there's 1 or 2 other groups that are working on it. I do know that Dr. Peter Locon, he wrote a dissertation called Resonance, the Science Behind the Art of Sonic Drilling, which is also a great title. And that talks a lot more about it if you're interested, because I'm not the one to explain it any further than that. Okay, talking about additional capabilities and applications. I touched on the diamond drilling or dual drill heads already, but
I think Mike might be frozen for a second there. Oh, he's back. Sorry, Mike, you just
back,
froze.
yeah.
Yeah, we got you now.
Okay. Okay, so yeah, there's these dual drill head options. The middle picture here, this is an Eagle Camp rig. They do something very cool where they actually put both heads on the same trolley, so you can sonic drill, and then when it's time to switch to diamond drilling, you just slide the head over and use the diamond drill head. Photo on the right is one of our older ProSonic rigs with a pin-on or quick connect diamond drill head. It's the same idea. You sonic drill the overburden. Once you set your casing into rock, you can just relatively quickly pin these heads on. They take about half an hour at most. Super cool photo on the left here. This is a rock core collected with one of our sonic drills, and that's a 1,000-foot core mark collected with a sonic drill. Okay, we also touched on combination drilling, and so we have the options to combine sonic with diamond drilling, but we also have the options to combine sonic with mud rotary drilling, where you can use sonic to drill the more difficult or coarse materials and challenging materials. And then once you get into finer or more sensitive material, you can switch over to mud rotary and do more conventional mud rotary drilling and geotechnical sampling. A good example would be if you're working on a dam, for example, and it's got a riprap shell, you can drill through that with sonic and case into a softer kind of core material, and then switch over to mud rotary drilling and collect really high quality in situ samples and tests. We also have the option to deploy CPT. There's some sonic rig manufacturers that give you that option right from the factory as well. This photo is one of our custom built 20-ton CPT ram sets. Fun fact, actually, the first time we did this was for a bridge back in 2007. So nearly 15 years ago. Yeah, nearly 15 years ago. Very cool graphic here showing this kind of mixing CPT with sonic. So on the left is kind of what's happening right now. You're getting a standard CPT plot there with tip resistance, friction, and pore pressure. And then we would sonic drill over top of that and get a full sonic core that matches the CPT. So you get the CPT data, and then you also get the visual data and the sample of it. That's it. I mentioned borehole geophysics. When you're sonic drilling, you're installing a casing to full depth. It has very good contact with the borehole wall. So we've been able to complete downhole seismic right inside the casing. This application would be where we've used it, it's been very successful, is collecting downhole seismic over water, for example, or somewhere where you wouldn't want to install a permanent or semi-permanent casing. You've drilled the hole anyways. You would normally install a casing, wait for grout to set, and then come back and complete downhole seismic. But because the sonic casing has such good coupling with the borehole wall, you can actually complete downhole seismic right inside the casing. And that brings us to another example project. So this was a nearshore offshore project for port expansion. The big thing is that they were targeting significant depths, like more than 150 meters or 500 feet below mudline. And it was offshore, nearshore, in tidal waters. And they really wanted to optimize the information they collected in this like thick overburden, thick and variable overburden. And it was overlying dense tailor. That's what they were expecting it to be overlying anyways. So being on a floating platform, the solution was to use a sonic drill that was set up for combination drilling. So sonic plus mud rotary, plus CPT, plus vein shear testing, and seismic. So in the end, they ended up deploying CPT from the sonic drill with the portable ram set. When they hit refusal, they could drill out with the sonic, and then the hole was cased and they'd send the CPT back down again. And I believe they ended up reaching depths of over 160 meters and collected seismic data to those depths. Then they could move over to an adjacent hole and use the CPT data to target testing zones. And then they'd use the sonic to drill quite rapidly to those testing zones and set casing. And then they could switch over to mud rotary drilling and collect, I believe they did Shelby tubes and electric vein shear tests. So high resolution electric vein shear tests as well. And again, it was all done from a single platform on a floating platform in tidal waters. There's a lot of interesting applications for fully cased angled boreholes in overburden. This left photo is a site in Quebec, and a contractor was installing a cutoff wall for a dam. The cutoff wall had to be slotted into the bedrock, and the overburden was super dense and bouldery, and they kept mistaking it for weathered bedrock as well. And they were just generally having a hard time getting that bedrock profile. So they hired us to come out and drill these angled holes 20 meters into bedrock. So through the difficult overburden and 20 meters into bedrock to prove that it was indeed bedrock. And then they used all of that data to draw a better profile of the better bedrock profile anyways. The photo on the right was a mine site, and they were trying to assess the ore in an old tailings facility to potentially remine it. And the tailings were water capped at the time, and they couldn't reasonably get a barge like down into this pit. So the solution was to install these benches around the outside edge of the pit and then drill angled holes into the ore below the water so they could test it and assess it for remining. And then another application that we've done on the environmental side is installing vapor probes and monitoring wells underneath buildings where the conditions were probably too difficult for a small portable rig, or it was too invasive for the business that was operating. So you can set up the sonic drill or a mini sonic drill on the road outside the building, drill at an angle underneath it, and install monitoring wells and vapor probes and whatever other instruments you might need.
What is the maximum angle from vertical that you can do sonic drilling?
I mean, the maximum from vertical that we've done is 60. So 30 degrees from horizontal, 60 from vertical. I think that I think most of the rigs kind of come rated for 45, but I don't see any reason why you can't do more. And then I know that they're using sonic heads on construction drills for tiebacks and whatnot, and they're doing horizontal holes and inclined holes. But I do believe that there's some modifications that have to be made to the lube system on the heads if you're going past horizontal. An environmental or maybe hydrogeological application is this isoflow vertical aquifer profiling. So you can go out and sonic drill, collect continuous core and case as you go. And then if you find these zones of interest where you want to do a pumping test, you can drop this, it's kind of a packer and a screen down into the casing, and you pull your casing back and expose that screen. And then there's a small pump that fits down in the rods, and you can collect pumping tests. I think the application would be if you're doing vertical aquifer profiling, if you have a bunch of zones that you want to profile and you'd have to install a bunch of wells otherwise, you can do this all in a single borehole. And you're collecting sample the whole time, so you can identify those zones easily and just continue on advancing the borehole after the tests are done. Another water sampling option is these push-ahead discrete samplers. Again, regular traditional sonic drilling, collecting core, advancing casing. If you run into a zone where you want to collect water samples, you take the core barrel off and install the sampler. You deploy it on the rods, push it into the formation or vibrate it into the formation. It's just a couple of reverse rotations to disconnect the tip, and then you pull the rods back and expose this laser slotted screen, and then you can sample the water with like a Waterra or a Baylor or peristaltic pump or any of those kind of common water testing methods. Then of course you just pull the sampler out, put the core barrel back on, and continue advancing your borehole. There's options for polycarbonate liners that are actually housed inside the core barrel. So they're in there while you're drilling. The sample's collected directly into the polycarbonate liner. Then you just extrude the liner, put the caps on it, and tape it up. I think this is more of an enviro application anyways. There's a lot of winter and Arctic packages. These two, the photo on the left is in northern Alberta, an oil and gas site where we couldn't actually put a full enclosure because there's concerns about gas releases from the borehole. But they have the side tarps and they have steam generated heat inside for the workers and keeping the rig warm. And then the photo on the right was actually in northern or central Alaska in the middle of February. The crazy thing about it is they were getting daytime highs of -35. So they were seeing weather much colder than that, but when it's a daytime high of -35, that can be very challenging. Inside the enclosure, though, they were getting, close to room temperature, high 60s in Fahrenheit or high teens in Celsius. There's entirely hands-free tool handling options. Most sonic drills have some kind of tool handling or rod presenter because they do use kind of larger casing and rods. But it goes all the way to completely hands-off tool handling. The rig in the photo is an Camp rig. This you can buy from the factory with a casing handler and rod loader, and nobody needs to pick up any steel. I should note you often sacrifice production rates as tool handling becomes more automated, but I think most agree it's a small price to pay for the decreased safety risk. And we have these heli-portable sonic drills as well, and these are capable of everything that our other sonic drills are. It uses a Bort mini head, so it has the same capacities and capabilities as a Bort mini sonic. But then you can also do mud rotary and diamond drilling and SPTs and LPTs and CPT from this rig. Really anything you can do with the regular rigs, you can do with the heli-portable rig. It just takes longer. And I think I've got one cool video to show on that as well. All right. Yeah. So just to summarize, Sonic is ultra versatile. It can be used for so much more than just environmental drilling. There's a wide variety of rigs and capabilities, and selecting the right rig and the right setup for your application is quite important. You know, Sonic is not Sonic is not Sonic. They're not all the same, and you do need to select the right equipment and setup for your application. There's a lot of misconceptions about Sonic and where it can be deployed and how it can be used, and hopefully we debunked some of those anyways. But there are some limitations and considerations that you do have to be aware of and consider when you're thinking about Sonic for your projects. And I believe that's it.
Great, thank you. I just saw that there's also questions coming in on the chat. I tried to note that. So we are recording this. Everyone attending and everyone that had signed up and is not attending live will get a link to the presentation to watch it. And you're welcome to share that with your coworkers. We have a lot of questions. Jeff, I don't know, have you sort of organized some of these, or I know some of them are along the same lines and
Yeah.
focusing on topics.
There's some double ups, yeah.
Yeah.
I've addressed some of them, but yeah, there's a lot more. We could probably just start top down and go through a few. I think I did put one into
So yeah,
or
one of the
Kelly, maybe
ones,
you see that, yeah, answer live when I've
yeah.
clicked yeah.
So some of them, there's quite a few asking Mike about sort of like higher quality or undisturbed samples. So maybe you can just address that, like what to do in soft collapsible soils. Can you get Shelby tubes, that kind of thing?
Yeah, for sure. So it again, you know, comes back to that combination drilling. I think if you're in soft soils, yeah, it really depends, and I can't speak too much to the sonic disturbance. In our experience, more cohesive materials, you see considerably less disturbance from sonic. Once you get into sands and liquefiable materials, you do see some disturbance from sonic. But I see the same thing with mud rotary. When we've had clients that really want high quality Shelby tube samples in something that's more silty than it is clay, we'll often do the combination drilling. So you drill to that zone with sonic, and then we'll just switch over and mud rotary drill another kind of 5 feet and then collect the Shelby tube and using a piston sampler or something along those lines.
Okay, and we talked about kind of the disturbance at the bottom of the borehole that you can see, like if you drilled and then immediately started pushing CPT, that's
Yeah.
also stress relief. Just for everybody's knowledge, the exact same thing happens in a mud rotary borehole. You get stress relief if you started pushing a CPT right at the top, the very end of the borehole, you'd see the exact same thing. Um, so somebody asked about if you're doing blow counts, how does that sort of affect the end value?
Yeah, I mean, I think it affects the end value the same as any other drilling method. It was kind of my point, right? I think that you know, I'm a CPT guy by nature, so I would argue to use CPTs where you can. But yeah, mud rotary drilling, hollow stem auger drilling, all of those are going to relieve the overburden stress. You have potentials of jetting and mixing with water or stirring up your sample, and the beginning is going to be disturbed and your blow counts are going to be lower. In practice, I think that most of the time you insert your SBT and it kind of falls through that slough and it gets into the less disturbed material, and then you collect your SBT. And that's the exact same thing that happens with Sonic. again, in our experience, we haven't seen a vast difference in blow counts on holes that were drilled with sonic compared to holes that were drilled with mud rotary or augers. That's not true 100% of the time, but I also think that two different mud rotary rigs can give you different blow counts.
Yeah, and if anyone's ever measured the energy from hammers, there's also that variation too. So,
for sure.
Okay, so a couple of questions about specifically for tailings, like how does sonic do in drilling through tailings? And is there any chance of it promoting like a trigger to tailings liquefaction, with the vibration?
Yeah, I mean that's a big question for sure. We use it extensively in tailings. I actually mentioned that Aqualock sampler, which is used for very, very fine tailings. We use it extensively in oil sand tailings and collect nearly fluid samples with it. And then we also use traditional sonic coring to sample like metal mine tailings as well, and not had any issues. Part of the study that we did with UC Davis, and it's noted in the paper, is that we actually did install, we called them sonic ones, but they were pore pressure transducers and I believe geophones in a kind of geometric pattern around the boreholes that we tested. So we also measured the vibration and pore pressure response as we advanced the sonic casing. It did indicate that there was some increased pore pressure response, but we also think that a lot of that is that a pore pressure transducer can act like a geophone. So if you vibrate a pore pressure transducer, then it does act like a geophone. So it was somewhat inconclusive, but I would suggest, if you're really interested in that, to read Jason's paper and look out for more research on that.
Yeah, I guess
Okay.
part of the
Yeah.
trick is, and I guess that's maybe where the research is wanting to go, how to separate the sonic induced disturbance from the other factors for disturbance, whether it's diameter, soil type, stress, depth, all those things, and material types and methods of advancement, to identify what is the purely the sonic induced disturbance. I think there's still ongoing research on being able to do that.
Yeah, for sure. For sure.
A couple questions relating to embankment dams. So I don't know if you wanted to touch on sort of hydraulic fracturing, like why you would use sonic drilling, for an embankment dam.
Yeah, for sure. So we see it a lot. I think FERC, right? I think that FERC specs sonic drilling for embankment dams now, and they might spec dry drilling. But the two main things that I would say is that you can drill dry and not use any fluids or inject any fluids into the formation. But then the other thing is that you can, when you are drilling more traditional sonic and you're using water to flush, you can control, because your hole is cased the whole time, you can really keep good track of how much water, where it's going. And on top of it, it's just clean water. But yeah, so embankment dams, were they concerned about injecting water, then they would typically drill dry.
Awesome. And then someone else asked about it for landslide investigations, and then also, heli-portable stuff, to give the option, for difficult access, but landslide applications.
Yeah, we have used it in landslides a lot. We actually have not used the heli-portable for landslides. We're usually there a good while afterwards, and they've already built roads or paths in that we can bring track rigs in for. But it's excellent for that, because a lot of the time the slide material is super mixed and variable, and they don't know what it is. There's often voids. So sonic drilling and advancing casing the whole way is really, in my opinion, the best option. You're going to get down there, you're going to get quality sample of it, and you can install those instruments like SAAs and inclinometers. And
Are there any kind of sonic rigs that have low clearance, like less than 10 feet for inside a basement or something?
less than 10 feet is getting pretty extreme. I think that there's probably some custom rigs out there. The rig in this photo is a compact rig built in the United States, and they're less than 20 feet. And I believe they have a short mast that handles 5 foot tooling, and it might get down to 10 feet. I know Eagle Camp makes some very small rigs, and then there's some small manufacturers that make custom rigs. I don't know of a particular off-the-shelf rig on the market that's under 10 feet, though.
Some questions about sonic coring. There's a lot of questions. Sorry, I'm scrolling
Yeah.
too quickly.
The mud rotary
Yeah.
topic is coming up a lot, or the Shelby tube. Sorry to interrupt, Kelly.
Mhm.
The Shelby tube and the switching between mud and sonic, and can you just turn off vibes prior to doing a Shelby tube if you're
Yeah.
in a clay or approaching a clay zone that you want to target for sampling? That's coming up a lot.
Mhm.
Um, Maybe just reiterating
Yeah.
that method and recommended procedure there, Mike.
Well, all of these questions come up a
Yeah.
lot, and I think it's at the discretion of the geotechnical engineer, the mining engineer. You can certainly reduce the amount of vibe. I would argue that you're probably going to cause more disturbance by having like a rough or what we call a dirty vibe as you're coming up to those depths. You can advance your core barrel without vibration as well, but then if it's clay, the skin friction inside the core barrel can be an issue, and then you're just kind of pushing your core barrel in, and that can cause more disturbance too. Uh, our rule of thumb, not even rule of thumb, I'd say what we do most often, and it's prescribed by our clients, is that we'll stop 10 feet ahead of the sample. So we'll sonic drill, and if we are targeting it, we'll stop 10 feet ahead and we'll drill 10 feet with mud rotary before we take those kind of higher sensitivity samples. If you don't know what's there and you haven't done your CPT yet, then it might be, okay, we've hit that more sensitive zone now when we've collected a sample of it. We'll just drill 5 feet and take our Shelby tube, in the hopes that we don't get out of that zone. And then if that tube's good, we can drill another 5 feet and take another tube.
Yep.
But yes, there's
Yep.
options. You can use no
Yeah.
vibe, you can reduce the vibe, you can use more vibe, you can use less water. But yeah, I don't have any straight answers on which one's the best.
Mm.
Some people are asking about sort of the drilling through rock core. For example, that one that you showed that was marked at 1,000 feet, was that all drilled sonic, like 1,000 feet of sonic?
No, it's probably 600 feet of sonic, 400 feet of rock core.
Okay, and then for sonic, is there a way of sort of what's the word I'm looking for? Like orienting the core to like determine fracture planes and stuff like that?
Not with sonic core, and you're not going to
Okay,
get you wouldn't use sonic for that because you're likely going to mechanically fracture the core anyways with the sonic.
okay.
But
Mhm.
for sure, once you switch over to traditional diamond drilling, you can orient the core, and all those angle holes we use oriented core.
Okay.
There's on a similar thread, there's a question around, I think measuring deviation.
Mhm.
So if you are on an angle, or vertical, and if you wanted to know where you are, where you're going with your borehole, there's ways to put tools down the casing, Mike,
For
to
sure,
assess
yeah.
that. Yeah. Okay.
Yeah, super common with we've done a few projects for stuck TBM. So tunnel boring
Mm.
machine gets stuck and they need to be able to pull it back from the face. And they install freeze tubes so they can freeze the formation so it doesn't collapse when they pull the TBM back. And obviously those freeze tubes need to be really close to the face of the TBM, but you don't want to hit it. So we drill down to about the elevation of the TBM, and then to log the casing ahead of time and make sure we're not going to hit it. The most common method is that we'll put SI casing inside of the sonic casing with centralizers, and then just use regular SI tools to log it for inclination. But we've also just sent down our HQ casing with our HQ drill rod, I guess, with centralizers, and then you can run deviation tools through that. So any of the common deviation tools you can just put into your sonic casing with centralizers and measure.
Gotcha.
Yeah, how about drilling in like boulders or bedrocks? Some people have had issues of where, they've had problems with sonic. I don't know if you have anything to comment on there. I'm sure it's like a very site-specific issue.
Yeah, yeah, ultra site specific and rig
Yeah.
specific and all kinds of things. I can tell you that it certainly can be challenging, especially, like boulders suspended in fines can be really tricky because, they might move around as you're trying to drill through them. Yeah, in general, you can certainly drill through boulders and slide material and cobbles and those types of things. It can be challenging, and smaller uh, mini rigs, if you will have a more difficult time with that than a bigger, more powerful rig.
There is one real quick, maybe we should address this. Our sonic drill rig operation, are they very, very noisy?
They're noisy, yes. There's some noise studies out there. I don't recall what the numbers are, but they are noisy, yes.
Let's see, maybe we can just do a few more. I know we're over time, but there's still over 200 people with us, so we can answer a few more. Okay, we did high quality samples. Somebody who was asking where our sonic rigs are. So if you're interested in cone tech capabilities, in the US, we have sonic rigs out of Salt Lake City. And then also our Mike is based in the Vancouver area. So there is sonic capabilities all throughout British Columbia that could be mobilized, just across the border if you're a little bit closer to the northwest there.
And we mobilize sonic rigs globally.
Yeah.
Yeah, we're very North America wide, and we mobilize sonic rigs globally, but obviously has to be cost effective.
Yeah. Somebody asked on swapping between sonic and mud rotary, do you reuse the same mud tub for both the sonic as you would for mud rotary, or do you have to set it up like a separate fluid system?
Yeah, really depends on the project. More often than not, we'll use a mud puppy or mud slayer, like a mud cleaning system for the mud rotary, and we'll recycle the mud for the mud rotary portion only. And then when we're sonic drilling, we're just doing traditional sonic methods, just using water. You can't actually pass the recirculated mud through the swivel on a sonic head, so we install underhead swivels. We have a few different options for them. And we do have some that you can vibrate as well. So you could vibrate with mud if you wanted to, but typically they're kind of two different processes. You got your traditional sonic drilling with water, and then you've got your mud rotary drilling, and you're keeping them separate from each other and using separate muds.
Okay, and so maybe just the last question here. Somebody was asking more on the environmental side. How can they minimize volatilizing gases that are crucial to analysis when you're doing sonic drilling?
Yeah, yeah, that's a bigger topic as well. Yeah, trying to keep the temperatures down is the important part. So when you're into difficult drilling, temperatures do increase, and then you typically use water to decrease those temperatures. I'm not sure how that affects your gas issues. I assume that traps the gas, but I'm really not sure. I know it's talked about a lot, and I think what they usually ask us to do is to advance slowly and minimize the heat production.
Great. Okay. Well, if we did not get to your question, we will email you about it. So we'll be able to get a printout of all the questions. And thank you everybody for joining in. Follow us on LinkedIn for updates on stuff. And we will be doing another webinar on December 17th. This one's back on CPT and sort of evaluating piezometric profile and applications for mine tailings and dam investigations. Thank you everybody for joining. Thank you so much for the presentation, Mike. Really, really great and super informative.
Yeah, thanks everyone for joining, and thanks for putting it together, Kelly.
Yeah. Okay. Goodbye.